Hello and welcome to my YouTube channel called Statistics from A to Z, Confusing Concepts Clarified. These videos are based on content from my book of the same name, which is published by Wiley. For more information on the book and these videos, please visit statisticsfromatoz.com. This is the fourth video I'm making on errors in statistics. Earlier, I had done one on residuals, which are a type of error that we find in regression analysis. And I'd made another video on standard error, which is the standard deviation of a test statistic. It is a very confusing concept, which my video clarifies. And then there's one on statistical errors in general, which include the subjects of this video, alpha and beta errors, as well as the video to follow this one on margin of error. See statisticsfromatoz.com/videos on my website for the latest status of my videos completed and planned. As usual in the book and in these videos, we'll start by going quickly through a list of keys to understanding, or KTUs. This will give you the overall picture of the concept on a single page. After that, we'll go into a detailed description of each of the keys. For this video, there are 4 KTUs. Here is the first one. Number 1, there is a risk of an alpha, also known as type 1 error, or a beta, also known as type 2 error, in any inferential statistical analysis. KTU number 2 is a table which compares and contrasts alpha errors versus beta error. There are 7 points of comparing and contrasting, which should help clarify each of these 2 concepts. Key number 3 says there is a trade-off between alpha and beta errors. Key to understanding number 4 says to reduce both alpha and beta errors, increase the sample size. And here on one page are all 4 keys to understanding the types, uses, and interrelationships of statistical errors. You may wish to pause the video at this point and read them all together. Okay, let's go back to the top and take a more in-depth look at each key to understanding. KTU number 1 says there is a risk of an alpha, also known as type 1 error, or a beta, also known as type 2 error, in any inferential statistical analysis. All right, first, what is inferential statistics? Inferential statistics is not like descriptive statistics. In descriptive statistics, we have complete data on the entire universe we wish to observe. So we can just directly calculate various properties like the mean or standard deviation. For example, we know the number of points scored by a given basketball player in each of their games. We can add up all these points and then divide by the number of games to get the mean points per game. This is a descriptive statistic. On the other hand, inferential statistics use methods like hypothesis testing and confidence intervals because we don't have the complete data. The population or process is too big or it is always changing, so we can never be 100% sure about it. The best we can do is collect a sample of data from the population or process and make an estimate from that. Since it's an estimate, there will always be a chance for error. This error is called a sampling error. There are 2 types of sampling error, and they are like mirror images of each other. It may be easiest to think of the 2 types of sampling error as false positive and false negative. The second key to understanding is this compare and contrast table for alpha errors versus beta errors. To see how they are different from one another will help us to get a more intuitive understanding of each of the 2 concepts. Let's go through the table row by row, as designated by the blue arrow on the left. First of all, an alpha error is a false positive. It might make it more memorable to think of an alpha error as seeing something that isn't there, like a unicorn. A beta error is the opposite. It is a false negative. It is like not seeing something that is there, like the fact that smoking causes cancer. Moving on down the table. So what is an alpha error, also known as a false positive? It is the error of concluding that there is something, say a difference or a change or an effect, when in reality there is no difference, change, or effect. A beta error, also known as a false negative, is the opposite. It is the error of concluding that there is nothing happening when in fact something is. For example, if the statistical analysis of a process mean concluded that it had not changed over time, when in reality the process mean had changed, that would be a false negative, a beta error. The next row in the compare and contrast table tells us what these errors mean in hypothesis testing. If the test rejects the null hypothesis when the null hypothesis is in fact true, that is a false positive, an alpha error. If the null hypothesis is actually false, but the test fails to reject it, that is a beta error, a false negative. There are several other names for the alpha error, like type 1 error and error of the first kind. Colloquially, it has been called a false alarm or a crying wolf. And the beta error is also called a type 2 error or error of the second kind. But the concepts of alpha and beta errors are used not only in hypothesis testing, but also in other inferential statistics methods and tests like confidence intervals, t-tests, ANOVA, etc. As an example, in a blood test, an alpha error, that is a false positive, will indicate that there is a disease present when there is not, while a beta error will fail to find a disease that does exist. And finally, the probability of an alpha error is p, and the probability of a beta error is beta. I keep saying that statistics is confusing for everybody, even very intelligent, otherwise very technically competent people. Here's another example of why. Beta is the calculated probability of a beta error, but alpha is not the probability of an alpha error. Alpha is a number the tester selects. It is the maximum probability for an alpha error that the tester will accept. Most commonly 0.05, that is 5%, is chosen. 1 minus alpha is called the confidence level, and 1 minus beta is called the power of the test. KTU number 3 says there is a trade-off between alpha and beta errors. Now this makes sense. Consider the situation of airport security scanning. We want to detect metal weapons. We don't adjust the scanner to detect only metallic objects which are the size of an average gun or knife or larger. That would reduce the risk of alpha errors, that is identifying coins as possible weapons, but it would increase the risk of beta errors, that is not detecting small guns and small knives. This is the reason why we don't select an alpha, maximum tolerable probability of alpha error, which is much smaller than the usual 0.05. There is a price to pay for making alpha extremely small, and this price is making the probability of a beta error larger. So we need to select a value for alpha which balances the need to avoid both types of error, and the consensus seems to be that 0.05 is good enough for most uses. Here are some more examples of trade-offs between alpha and beta errors. You may want to pause the video at this point to read them. KTU number 4 says, to reduce both alpha and beta errors, increase the sample size. When it comes to alpha and beta errors, increasing sample size is like the universal cure. There are other factors involved, but increasing the sample size will reduce both alpha and beta errors. If the sample size is relatively large, increasing it further will yield diminishing returns and error reductions. There are 2 articles in my book on sample size and 2 corresponding videos on YouTube. And that's it for the concept of alpha and beta errors, which is the 4th video in this list. As I mentioned earlier, here are the 3 videos I had previously uploaded. And coming next is a video on the margin of error. If you liked this video, please remember to press the thumbs up like button on your screen below. I'll be making more videos of some or most of the 60 plus concepts in the book if folks like you tell me more videos are wanted. Please subscribe to this channel to be notified when new videos are uploaded. Also, the website statisticsfromatoz.com has a listing of available and planned videos. Now, videos like this can be very helpful, but they're not very handy when you want to quickly look up something on the job while studying or during an open book exam. For that, nothing beats a book or an ebook. You can also learn about those on the website. I'd recommend following my blog at statisticsfromatoz.com/blog. I got some things there that hopefully you will find interesting, like a statistic tip series, as well as posts showing that you are not alone if you are confused by statistics. I'll also be posting on the Facebook page, Statistics from A to Z, and on Twitter as @StatsA to Z.